can't believe it. We were so depressed. And it took us 24 hours before we figured out why it wasn't there. But in a group this size and this smart, there's usually someone right away who figures out why we didn't see this wave of obesity in this situation.
No pressure.
No pressure, exactly. Any ideas as to why? Well, yeah?
Well, two things. I mean, one, the image that you had, I mean, the topology was changing all the time. It was very hard to see anything spread out when you've got nodes moving around.
True enough.
And they're not in the same places. The second thing is you mentioned at the beginning that you've only got 3 degrees out relationship with others, which would mean that potentially these kind of waves wouldn't propagate in that fashion if they even existed in the network.
Okay, those are both very good points. The first point, we optimize the image to minimize the motion anyway, and it's about as good as you can get, although I take your general point. The second thing is we're going to come to this like 3-degree thing, and one way to think about it is a loose spring versus a tethered spring, another physics example. So, you know, you have the spring that you wave, like the slinky on the floor that's untethered. You guys must remember this from college physics, or the slinky on the floor that's tethered. And actually, whether you get a standing wave or not has a lot to do with that, and we can talk about that. But anyway, so no, actually, the reason is that obesity is not a unicentric epidemic. It's a multicentric epidemic. And the proper analogy is not a single pebble being dropped on the surface of a still pond. Rather, it's a whole handful of rocks being thrown on the surface of a still pond. So every individual pebble still causes this little dispersion, these waves that spread out, which incidentally could reach the perimeter, come back, and cause interference. So you get standing waves on the surface. But also, there's so many that you get a choppy surface. But it doesn't mean that a single pebble isn't causing a disturbance. It means you need a different set of techniques in order to uncover this than you would otherwise. So we resorted to a variety of other ideas to identify this. Yeah?
Did people influence larger people? Did you find that, or were you just looking at it from the point of view of...
No, thinness spreads and weight gain both spread. And why weight gain wins out has to do with another fundamental property of social networks, which is that networks tend to magnify whatever they are seeded with, but they need to be seeded. And so there's an exogenous force that's acting on the network that's causing people to gain weight, like changes in our society at large. We can discuss those. And that motive force is always there. It's like the hand dropping rocks. There's no wave on the surface until you drop a rock. And so that's why, on average, obesity wins out, even though both phenomena can spread. Yeah?
Same group of people over the 30 years this week?
Yes, these are fixed.
Does this like get normalized with the effect of aging on average obesity?
Yeah. Yes.
So I'm under the understanding that the main focus for obesity, the main driving point for obesity is reputedly increasing portion size of meals. So it's an environmental influence on individuals over that same period of time.
Yeah, but our work is not intended to suggest that this is the only cause of obesity, but rather that this is an additional factor, a magnification factor. And so the example we give in response to your question is, imagine an island in the middle of the Pacific with a population on which there's no epidemic until the sailor washes ashore and bringing with him a germ. Now this germ can spread in this network population. So some exogenous force comes and then the network takes over. And the architecture of that population on the island could have a lot to do with how it spread. Actually, I'm going to keep going right now. We'll come back to more questions. So one of the things we took advantage of, because we have some other cooler stuff that I think will animate more questions. So one of the things that we took advantage of was the directionality in the network in our effort to identify the effects that were here and try to make some claims about whether they were causal. And here's the way this argument works. So I could nominate James as my friend. And we're going to call that an ego-nominated friendship. It's not because we're from Harvard. It's just because that's a technical network term. So I'm going to say this is an ego-nominated friendship, okay? Now James could reciprocate. James is my alter. He could reciprocate the nomination, and we'll call that a mutual friendship. We both nominate each other. And finally, James could say I'm his friend, but I might have no idea who the hell he is, okay? This was my experience in high school. I thought all these people were my friends, and they had no idea who I was, okay? So now, in which of those three circumstances do you think James's weight gain would be most likely to cause my weight gain? Mutual. We're very close friends. His weight gain is going to influence it. Second, which would you think?
He thinks you're his friend.
Other way around. I think he's my friend, the ego-nominated friendship. So I know James, I admire, I esteem him, I respect him, I'm following what he's doing. Things that he does will influence me. And last, if at all, the alter-nominated friendship. Because James says I'm his friend, he's gaining weight. I have no idea who the hell he is. I'm not watching his weight. I'm not interested in what he's doing. So I should be unaffected. And the reason this is crucial is that if it's the McDonald's opening up nearby that's causing me and James to gain weight simultaneously, it should not respect the directionality of the tie. McDonald's doesn't care whether I nominate him or he nominates me. So if we find a patterning conditional on the directionality, it should bolster our confidence that something in him is what's causing something in me. And sure enough, that's what we find using a family of regression models, which I won't go into the details right now. We find that if an ego-perceived friend gains weight, it increases my risk of weight gain by 71%. If my mutual friend becomes obese, it almost triples my risk of obesity. An alter-perceived friend has an effect indistinguishable from zero. And we looked across in the paper, there are more details, and in the book we discuss this across a variety of other kinds of same-sex friends affect each other, opposite-sex friends do not. Same-sex siblings may have a bigger effect than opposite-sex siblings. Spouses, we look at immediate neighbors. We also look at coworkers. Coworkers at small workplaces affect each other, but not coworkers at large places. And we've looked at a variety of other phenomena, which as well, we've looked at smoking behavior, and we found this interesting thing with respect to smoking behavior, which is that whole groups of interconnected smokers who don't necessarily know each other quit synchronously at once, like they quit in droves. It's like a flock of birds changing direction, except now we're observing humans smoking instead of birds flying. So this interlocked set of people will suddenly go from one state to another out to about 3 degrees of separation. We've also begun to look at other things like emotional states.
Right, and so here what we wanted to do is rather than looking at health behaviors, we wanted to look at affective states and try to think about, okay, so it seems like people are copying each other's behaviors. What about their moods? So the very first thing that we looked at was happiness. And so here what we have is another network picture. What we have is each circle is going to be a person. The circles are women and the squares are men. And we colored them according to whether or not they were happy or not, psychological measurement of whether or not they were happy, standard used in the literature. And so the yellow nodes are happy, and the blue nodes are sad. Blue, get it? Okay, that's fine. And we also have different colors for the different ties. And so we've got red for friend and spouse ties and black for the sibling ties. And you'll notice here, much more strongly than you would notice in the other work, there's this clustering that goes on. Once again, we find that it goes out to 3 degrees of separation. And here what we find, contrary to the obesity results and to the smoking results, is that happiness and unhappiness tend to spread differentially. Now, Nicholas and I had a bet about this going into the analysis. Before we looked at it, Nicholas thought that unhappiness would spread more easily. And he was making the evolutionary argument that, well, if something is making me unhappy, it's probably something that's going to make me less likely to survive or to reproduce. I'll let you sort of think about what those scenarios might be. But he really had this idea that
bad news would spread fast.
Bad news, that's right. So, whereas I had this more optimistic appraisal of what might happen, and that is that one of the reasons why...
It's one of the few bets he won, by the way. That's why he insists on telling the story.
One of the reasons why you would expect happiness to spread is because happiness reinforces trust and reinforces cooperation in social networks. And cooperation, as we know, is one of the things that makes human beings different from other species. We cooperate with strangers in large-scale societies, much larger scale than any other species. And so when we broke it down, what we found was that, in fact, I was right, that happiness actually spreads more reliably than unhappiness. And what's interesting about this now is that it's consistent with something else that we find up here. I don't know whether you can see it or not, but the blue nodes actually tend to be more on the periphery of the network, and the yellow nodes tend to be more in the center. In other words, happy people are more likely to be in the center. And we can use the overtime information to show that when you become more central, you actually become happier. And the reason why this would be true is that if you have these happy waves and unhappy waves both spreading through the network, but happy waves are more reliable, then being at the center makes you more likely, on average, to catch more of these happy waves relative to the number of unhappy waves that you would catch. I'm sorry?
Which comes first?
What do you mean, the network or the...
Do happy people become central, or do central people become happy?
Central people become happier.
A vindication of another high school claim that you used to make, that if you would only be more popular, then you'd be happy. But you were right.
That's right. But we found it didn't work in reverse. So happy people tend to stay put. Right? And if you think about it, that sort of makes sense. Why should I bother trying to change my social relationships if I'm happy with the ones that I have now? And so this was yet another case where we found these network properties having a big effect on things that are really important to us every day.
Yeah, I mean, this was, to our knowledge, this was the first time such a picture had been drawn, looking at human emotions rendered in this kind of network sense. There's been a bunch of work that's by us and others since then looking at these kinds of